Trigonometry is another area that you're going to have to be very familiar with in order to solve physics problems. And if you were to rate how comfortable you are with trigonometry right now, and you try to think of where you would be in that scale, well, the good news is that most students in physics have a lot less trouble with trigonometry than they do with algebra. Algebra seems to be much more difficult to work with and to figure out than trigonometry. So we're going to take some time to teach you everything that you need to know from trigonometry in order to be able to do your physics in roughly 1 or 2 class sessions here. Trigonometry, at least as we look at it in physics, relates to right triangles. And you might say, why would right triangles be so important in physics? Well, we're going to find out that they are. All sorts of things can be represented by right triangles in physics. And let me just give you an example of that so you can see where all this is going. Let's say we have a hockey puck. Overhead view here of a hockey puck sitting on the ice. And let's say 2 players simultaneously get the stick on the puck and try to whack it in different directions. And let's say the one player slaps it in that direction with a force of, maybe 60 newtons. Newton is the unit for force in the SI system. At the very same time that's happening, somebody comes from over here and slaps it in this direction, in a perpendicular direction, with a force of 80 newtons. And one question we'd really like to know is what's going to happen to the puck? Those 2 forces are equivalent to what total or what net force acting on the puck. And one of the things that we learned that we can do is we can take those 2 force vectors, the 60 newtons to the right and the 80 newtons directed upward, and we can add them together by creating a right triangle. And the net effect of those 2 forces would simply be whatever that green vector works out to be. And we can figure out the length of that vector using the Pythagorean theorem, and we can figure out the angle that vector makes using trigonometry. So trigonometry allows you to find unknown angles and unknown lengths in right triangles. And that's something that when we're looking at force vectors and momentum vectors and lots of other things in physics we'll be interested in doing. So that's our motivation for wanting to understand trigonometry. So anytime you have a right triangle, there are 5 different things you can know about it. There are 3 different legs, or 3 different sides rather, the legs A and B, capital A and B, and the hypotenuse C. All right, the lengths of the sides, the 2 legs and the hypotenuse. And there's also the measures of the 2 acute angles, little a and little b. Now the 3rd angle in the triangle is the right angle, and we know that's 90 degrees. But the other 2 angles are things that we might be interested in knowing, because we wouldn't know them off the top of our heads. Well, we already kind of mentioned that if you know 2 of the sides of the right triangle, in this case we know the 2 legs, 3 and 4, you can always find the other side, in this case the hypotenuse, using the Pythagorean theorem. And probably you learned this somewhere back in middle school. Pythagorean theorem says that the sum of the squares of the 2 legs, in other words a squared plus b squared, is equal to the square of the hypotenuse, c squared. Or we could say c is equal to the square root of the sum of the squares of the 2 legs. All right, so in this particular problem, if a is 3 and b is 4, c would be equal to the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, or the square root of 25, which is 5. And this is one that you may even have memorized, that 3, 4, 5 triangle is a right triangle. The legs are 3 and 4, the hypotenuse is 5. The other thing is, if you know one of the 2 acute angles, you can very easily find the other one. Remember, the sum of all 3 angles in a triangle is always 180 degrees. So if it's a right triangle, one of the angles is always 90. That means the other 2 also have to add to 90. So little a plus little b has to be 90. So for example, if little a is 30 degrees, little b has to be 60 degrees. Those 2 angles are always complementary, which means they have to add up to 90. All right, so that's pretty easy to find. Don't need any trig to do that. But what if we don't know either of those two acute angles? What if we don't know little a or little b? Maybe we know the lengths of the sides of the triangle, but we don't know the angles. For example, in a 3, 4, 5 right triangle, anybody know what the sizes of the two angles are? That's not something that most people have memorized. If you said 30 and 60 degrees, you're wrong. Right? That's not correct for a 3, 4, 5 right triangle. To find it, we need to use trigonometry. And here's the central idea of trigonometry. If you take a triangle like the one on the left, and you scale it up by the same factor, in other words, you multiply all the legs and the hypotenuse, you multiply all the sides by the same factor. They're using a k to represent it here. What you get is a different size triangle, in this case a bigger one, but you don't change the size of the angles at all. So for example, if we take each of the sides of that triangle on the left and we make it 10 times longer, we get a much bigger triangle, but the sizes of the angles are exactly the same. It's always true for any triangle in the world that you look at. Well, how does that help us for anything? Well, let's say we have a triangle where we know the angle B is 60 degrees and the angle A is 30 degrees. And let's say for the sake of discussion that side A is 1 unit in length. It turns out that if the angles are 30 and 60 degrees, if the side opposite the 30 is equal to 1, like we have a diagram here, the hypotenuse of that triangle will always be 2. In other words, there's always a 1-to-2 ratio between sides A and side C. And you may remember this from geometry. You may have called this a special right triangle, a special angle of 30 degrees or 60 degrees. The hypotenuse is always double the side opposite the small angle. It turns out that every triangle, not just the special triangles, have ratios like this that you can either memorize or look up. Or in the case of our calculators, they've been programmed to give you these ratios. Well, there are 3 pairs of sides possible. There are 2 legs and there's a hypotenuse. So that means there are 3 different sets of ratios that you could talk about for any triangle. And they give them mysterious names, at least if you've never seen them before. They're called the sine, the cosine, and the tangent. Now for the sine, we use SIN, 3-letter abbreviation for it. In fact, if you have a scientific calculator and you look at your keypad, you'll see that one of the buttons has that SIN on it. For cosine, we use COS to represent it. And for tangent, we use TAN to represent it. These are called the 3 trigonometric functions, and all they are ratios of sides of right triangles. The ratios are already calculated. They're stored in your calculator, or actually your calculator is programmed to be able to get them. All you have to do is learn to use them. So what are the ratios? What are the formulas? Well, for sine, the sine of any angle is simply equal to the side opposite the angle divided by the hypotenuse of the right triangle. The cosine of any angle is equal to the side adjacent the angle divided by the hypotenuse of the right triangle. And finally, the tangent of any angle is equal to the side adjacent the angle divided by the side, it's equal to the side opposite the angle divided by the side adjacent the angle. All right, so sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. How do you remember that? Because that's something you'll be using time and time again. Well, there's a mnemonic device, which means a memory aid, called SOHCAHTOA that will help you with this. Now, how does SOHCAHTOA help you? Well, first of all, you have to remember how to spell it. And I've heard people say that this looks like a Native American name, so maybe this is Chief SOHCAHTOA, the great Native American trigonometrician. I think I made up a word there. But the SO in SOHCAHTOA, S stands for sine, O stands for opposite, H stands for hypotenuse. So if you remember that, that tells you sine is opposite over hypotenuse. Then the Ka in SOHCAHTOA, C stands for cosine, A for adjacent, H for hypotenuse. And finally the TOA T for tangent, O for opposite, A for adjacent. So if you can remember SOHCAHTOA, you can remember each of those ratios and how they're defined. Well, how does that help you for anything? Right, those are the definitions. What does it all mean? Well, before we can get to that, we better make sure we understand what we mean by opposite, adjacent, and hypotenuse. Hypotenuse, that's the easy one. Hypotenuse of a right triangle is simply the longest side of the triangle. It's the side opposite the 90-degree angle. And that never changes. The opposite, though, is the side directly across from the angle you're considering. Which side is opposite depends on which acute angle you're looking at. And the adjacent is the side adjacent to or right next to, right beside the angle you're considering. And that changes also depending on what angle you're looking at. So for example, let's say we're looking at angle B in this triangle, which is this top angle. If we look at angle B, then side A is the side adjacent angle B, because it's right next to it. Side B is the side opposite angle B, because it's directly across from angle B. And side C is the hypotenuse. Hypotenuse is always the longest side. But if we were to switch angles, instead of looking at angle B, let's say we look at this angle A down here in the lower left, then the opposite and the adjacent switch. Now the opposite is A, right? Because now A is directly across from little a, and the adjacent is capital B, because now capital B is right next to or adjacent angle A. But once again, the hypotenuse is C, because that never changes. That's the longest side. All right, knowing that terminology, let's take a look at an example. Here we have a right triangle in which we have a 30-degree angle. And let's say we want to find the sine of that 30-degree angle. Well, we have to look at the lengths of the different sides of the triangle, because the trig functions are ratios of lengths. And notice we've been given the length of A is x. And if A is equal to x, what are the lengths of the other leg in the hypotenuse? If you remember your special triangles from geometry, you may remember that the other leg in a 30, 60, 90 triangle is simply the short leg times the square root of 3. So side B is whatever A is, which is x, times the square root of 3. And the hypotenuse, you may remember, is always double the length of the short leg. All right, so that's the first thing you need to do. Before you can take the sine, cosine, or tangent of an angle, you have to identify the lengths of the sides. And then, if it's the sine of the angle we're looking for, we need to think about what ratio we need. Well, sine, go back to SOHCAHTOA. Sine is opposite over hypotenuse. So the sine of 30 is the side opposite the 30, that's the x, divided by the hypotenuse, which is 2x. So it's a ratio of x to 2x. The x's cancel out, and you're left with 1/2. Therefore, the sine of 30 degrees will always be 1/2 or 0.5. And that's something you can try on your calculator. So I'd like you to go ahead and do that. And pull out your calculator. All right, so here's our calculator camera view. The very first thing I want to do is make sure I'm in the proper mode. So on your calculator, press the mode button. And somewhere down there you should see a choice between angles measured in radians or angles measured in degrees. All of our angles are going to be measured in degrees, so make sure you have that set for degrees. Then you can hit quit to get out of there. And to take the sine of 30 degrees, all you should have to do is press the sine button. As soon as you do that, you should see the sine appear on your display, and then type in 30. Close the parentheses, press enter, and that should give you 0.5. Make sure you're getting 0.5 when you take the sine of 30 degrees. If you mistakenly have your calculator in radian mode, we'll talk about what a radian is later in the course, but if you have it in radian mode, you're going to get negative 0.988 instead of 0.5. So if you're getting negative 0.988, that just means your calculator is not in degree mode. So go back in there and change it to degree mode, And when you do that, you should get 0.5. If you can't figure out your calculator, come and see me and I will help you with that.